Welcome back, students. From today we are going to start chapter number 3, and this is the assessment problem 3.1. Here for this circuit which is shown here, we have to find out the voltage across the source, the power delivered by the source, and the power dissipated at around this 10 ohm resistor. So in order to calculate the all the quantities which are defined here or which are given here, first of all we have to calculate the equivalent resistance, and we have to convert this circuit in the form which is feasible, like this one. We have to convert it into this form. So this resistance is called the equivalent resistance. This is the 5 ampere source, so that from this circuit we can easily find out the value of V and the power dissipated by this circuit. Okay, so in part A, the voltage V will be equal to I into R. So this I is given, which is 5, but the value of R is not given. Similarly, for the B, the power delivered to the circuit by the current source. Okay, so this is the current source, and we have to find out the power delivered by this source, which we know that can be found out by this formula. We know the value of I, which is given, but we don't know the value of this V naught. Okay, this is V, or we can also call it V naught. Okay, so to find out these two quantities, we have to convert this circuit into a very feasible form which is given here. To calculate it, the first step will be here, which is converting all the resistors into the equivalent resistance. So here in first step, we know that these two resistors are basically in series with each other. Okay, so its form will be equal to like this one. Okay, let me draw it. So it will be like this one. These two resistors are basically here. This is 16, this is 64, this is 7.2, and this is 30. Okay, I'm not using the omega sign here because it is understood that these are in ohms. So I want you all to know that these are the resistances which are in ohm. The omega symbol is already here, and these are in ohmic form. So now these two resistors, after it, these two resistors are now in parallel. We can see that the 64 and 16 are in parallel, so we have to convert them into the format which will be like this one. Okay, so for calculating the equivalent resistance of these two parallel resistors, we will have 64 plus 16. So from here we will get 12.8 ohm. So it is now 7.2, this is 12.8, and this is 30. This is our source. Similarly, now these two are in series. Writing them in the feasible form. Okay, so now these two are in series, so converting into their equivalent form, we will have 12.8 plus 7.2, and these two will be here. This is a 20 ohm, this is 30, and this is a 5 ampere source. So now we can also see here that now these two are in parallel with each other. Okay, so to find out the equivalent of these two, we will have the R equivalent equal to 30 multiplied by 20 divided by 50, which is equal to 12 ohm. So this is the R equivalent, and now this circuit is of the form which we wanted. So this R equivalent is equal to 12 ohm. Okay, so we have find out the value which we needed. Okay, so after finding out the value, we can put it here, 5 multiplied by 12. So this is now 60 volts. We know the value of V naught now, 5 multiplied by 60. So this is now 300 watts. So we have calculated what we wanted. We have calculated this thing here. So now for part C, we have to find out the power dissipated in this 10 ohm resistor. So there are basically two formulas to find out the power dissipation by any resistor, which are the power dissipation are equal to is equal to V square divided by R, or I square multiplied by R. Now if we have the voltage across any element, we can easily find the power dissipated across that element. Similarly, if the current is passing through the element, we can also find out the value of the power dissipation here. So to find out the power dissipation, we should have the voltage here. So we have to calculate the value of V naught, which is here. So now to find out the value of V naught, we will use the current divider law, which is this 10 divided by 6 plus 10 multiplied by the voltage, which is here. So let me call it V naught double prime. V naught double prime, we have to find out the value of V naught double prime. But the hurdle now is that we don't know the value of V naught double prime. So first of all, we have to find out the value of V naught double prime. So to find out the value of V naught double prime, we have V naught double prime is equal to, this is this resistance. So this resistance is not that this 64, this is the equivalent resistance of the overall. So the equivalent resistance of this overall is now this 12.8, and this is now this 7.2. So we will deploy for V naught double prime, we will deploy this circuit, because now here we have the equivalent of these two resistors. So V naught double prime is equal to 12.8 divided by 7.2 plus 12.8 multiplied by the voltage, which should be here. So the voltage here is, let me call it V naught prime. So V naught prime is not known. Do we know the value of V naught prime? Yes, we have calculated it already, because when we find out the equivalent all of these three resistors which we went here, so this is V naught prime, and we know the value of this V naught prime, which is this small V naught, and we have already calculated it, that is 60 volts. 60 volts, yes. So putting the value here, we will have this 60. So after this 60, we will have the value of it, which is 38.4 volts. Okay, now the value of V naught double prime is known. Let me put it here at the location where it has to be put it. This is now 38.4. so the value when it is calculated is this one, which is the 24 volts. Okay, so the 24 volts is calculated now. So now to find the power dissipation, PD is equal to V square divided by R. The value of V square is 24 whole square divided by this 10. So when it is calculated, it was 57.6 watts. So it is the desired value which is asked in part C of this question. So in this overall question, the overall idea of this question was to find out the equivalent resistance, and the equivalent resistance from a circuit in which many resistances are connected in series or parallel combination. So first of all, we have find out the equivalent resistance of the circuit, and after it we obtained all the quantities which were asked to find in the question. So this was the question, but in this question the overall technique of finding the equivalent resistance from the back side of a circuit is formulated. So thank you so much, and I will see you in the next